So this is a really useless definition from Wikipedia. A random variable is a mathematical mathematical what? It's a mathematical formalization of a quantity or object that depends on random events. That means just about nothing to you guys, right? Like, I don't know what a formalization is, and it's kind of a waste of words to use the word random when you're trying to describe random variable. Like, it doesn't mean a lot. So to really understand this, what is a random variable? We need to see a few examples. Like, if I were somehow able to randomly select an MNU student and then take out a measuring stick, measure how tall they are, that would be an example of a random variable. It's random because we don't know precisely what that measurement is going to be until we perform the experiment. So before performing the experiment, it could be anything. And it's going to be determined by this kind of idea of randomness, by randomly selecting the student and then measuring them. Another example. If we go drive to the hospital and we say, please let us weigh the newest newborn here, they probably wouldn't let us. But if we did, that would also be random. Because before we get in the car and drive to the hospital, we have some idea, right? It's not going to be more than 30 pounds. But, we don't know the exact weight until after you measure it. So before measurement, you have this sense of uncertainty or the sense of randomness. And then MNU survives on donations from alumni. At the end of the year, they're going to announce how much donations we received. You can go check that out on the website. But before the end of the year, we don't know what's going to happen. We can kind of speculate about what might happen, but until it happens, we don't know what's going to be. So I hope from examples that this makes sense. A random variable is something that we can talk about, and we can even assign probabilities to certain outcomes, but we don't exactly know what it is, at least not right now. Okay? Today is going to be mostly just learning vocabulary words. I said this to Nora earlier, but this class in statistics, it's going to start off feeling really easy. I hope, anyways. It's going to start off easy. It's going to get more difficult. So if you're bored right now, just wait. It'll get a little bit more challenging. But today we're doing mostly vocabulary words. Like, if you conduct an experiment, the population, that's the group we're trying to make an inference about. The sample is just going to be a subset of the population that we are actually going to count or measure or study in some way. Here's an example. What if you want to know what is the distribution of body weight for adult males in the United States? You somehow survey adult males and you get 10,000 people to submit what their current body weight is. These might be easy questions, but somebody tell me, what is the population? How does that word apply to this situation? Male. Yeah, adult males in the United States. We're talking about a group of 150 million individuals, right? Well, maybe not quite 150 million, but 100 million individuals. That's the population. What is the sample? Yeah, it's only those 10,000 individuals that actually completed the survey. So there's a lot of individuals in the population that aren't represented by the sample, or in the sample, I should say. And I know, like I said, this maybe is super easy, but we're going to start from the beginning. The FDA is trying to determine whether omeprazole is safe for adult females suffering from heartburn. So maybe they enlist a group of women. Half of them are going to be given omeprazole. The other half are going to be given a placebo. Then, presumably they would sort of track side effects, track symptoms, see if it's effective, see if it's safe before they give the stamp of approval. What would you say is the population? Yeah, it's all women around the world that are suffering from heartburn. That's what we're concerned about. What is the sample?
Wouldn't there be two samples? Because you have two different groups.
Yeah, well, you're right. You're absolutely right. So you've got this sample of women that are actually going to be given the drug, and another sample that are going to be given placebo. Yeah. So good. The sample is always just a subset of the population you're trying to study. So new words, two new vocabulary words for you. A parameter is a characteristic of a population. A statistic is an estimate of the parameter. And this is not always true, but most of the time, we can never, ever, ever really know the true value of a parameter. So imagine you're a biologist, or you're an ecologist or something, I don't know, zoologist, and you want to learn about a specific species of kangaroo. One thing you could do is you could go out into the wild and you could find them, sedate them somehow, put them on a scale, and you could weigh them, and then you could learn something about their distribution of weights for adult kangaroos, right? In this case, what would be the parameter?
Would it be the red kangaroos?
The population would be all adult red kangaroos, right? That would be the population. The parameter would specifically be a characteristic of the population. And what we're doing is weighing them. So maybe the parameter would be like the population mean weight, right? Maybe that's what we're trying to study, or that's what we're trying to learn about, is what is the population mean weight? The statistic that we're actually able to measure is going to be the sample mean weight. Because there's more than 70 red kangaroos out in the world, right? But just feasibly, as a one biologist team, are you going to be able to go out and find every single last red kangaroo in the whole continent of Australia and weigh every single one of them? No, that's infeasible. We will never know the true value of the parameter. But what we can do is we can get an estimate of that parameter. A statistic is an estimate of a parameter, and in this case, our statistic is going to be the sample mean. Once we take these 70 measurements, we average them, we'll have a sample mean, it'll be an estimate of what the real population mean is. My third grade science class performed an experiment to learn about bread mold. And so what we did is we took 10 slices of bread, we made them slightly damp by like spritzing water on them, and then we put them in closed plastic bags and we put them in a drawer so they would be nice and dark. Every day we opened up the drawer and we looked and saw how many out of the 10 were moldy. And we recorded the number of days that took before each one showed visible signs of mold. So there's not really a population this time, but there's still a parameter. The parameter would be, how long does it take to see mold on a piece of bread, right? What would be a typical amount of time where you would expect it to take, like bread mold to become visible? And maybe the best way to say what we're talking about in terms of the parameter is like, what is the expected value of the amount of time that must pass before bread mold becomes visible on a soggy piece of bread? Yeah. And we can never really truly know that. Like, we'll never know the exact underlying distribution. We can only make observations like this, do experiments like this, and we can gather measured data, and we can calculate statistics like sample mean times, and that statistic will be a good estimate of the underlying parameter. But parameters of processes are actually things that we can't ever really know. We can get better and better estimates, but statistics as a field of study is also kind of like a philosophy. It's like, do we ever really know something? We only know what we can observe. We can gather evidence for things, but what do we ever really know about? A qualitative variable is one that places individuals or measurements into categories. For this reason, they're also called categorical variables. So this is, again, more vocabulary, right? The contrasting type of variable is a quantitative variable, and a quantitative variable assigns a number value. So if you go out to the Galapagos and you record the color of the first 100 finches that you see, is that a qualitative or quantitative random variable? It's qualitative because we're not putting a number to it. We're just sorting them into categories based on color. Yeah, so that is definitely a qualitative example. Same thing. This time we're looking at finches, and we are going to measure the length of their beak. Is it 7 millimeters, 8 millimeters long? I don't know. We're going to measure the beak length. Is this a random variable that is qualitative or quantitative? Quantitative. Yeah, the random variable is like after you catch a finch. The randomness is like what's the length of the beak going to be? That's the random variable. And this would be quantitative because we can actually put a number to that measurement. A discrete variable can have only a countable number of possible values. A continuous variable can have a continuous range of possible values. This might be the most difficult distinction to make between vocabulary words today, but we'll do examples and maybe you can pick up on what we're talking about. Okay, we're back in the Galapagos. This time we're looking for nests, and every time we come across a bird's nest, we're going to count the number of eggs that we find in the nest. So the random variable is like, okay, when I find the next nest, I'm going to count the number of eggs. It's random because before I actually take the observation, I don't know what it's going to be. Is that random variable going to be a discrete random variable or a continuous random variable? Discrete. We might say there's only a discrete number of eggs that can appear. It's either going to be 0 or 1 or 2 or 3 or 4 or 5. It's going to be a countable number. We cannot find 3.5 eggs. We can't find 4.1 eggs. So there's not a continuous spectrum of measurement. It's only discrete numbers of eggs that appear. That's a great example of a discrete random variable. Back to measuring beak lengths. Was beak length a discrete or continuous random variable? Yeah, that's a great guess because I'm trying to give you examples of everything, right? So we already did discrete. This is going to be continuous. And again, it's because that beak doesn't have to just be 7 millimeters or 8 millimeters long. It actually could be 7.3 millimeters long, or it could be 7.452 millimeters long. It could be anywhere on a continuous spectrum of length. So it's a continuous random variable. Okay. More vocabulary. If we talk about level of measurement, there are 4 levels of measurement. The first one is called the nominal level of measurement. And nominal means we are simply categorizing individuals or simply categorizing objects. There's no order and there's no ranking to these categories. They're just different categories. Ordinal. It's kind of based on the word order, where there's a bunch of different categories, but we have placed them in a naturally occurring order. It makes sense to order them or rank them as categories. Interval is where you are taking a measurement and you have different measured values, and the differences between measured values has some kind of meaningful interpretation. It'll make more sense when I show you an example. A ratio level of measurement is like an interval level of measurement. A ratio level of measurement is where I'm taking measurements. It's a number measurement. There's an interpretable, meaningful interpretation of the differences between the values. And also, what's special about ratio and different from interval is that in a ratio level of measurement, 0 actually means 0. And ratios between values also have meaning. It's actually kind of difficult to think of interval levels of measurement because so many things that we do fall into the other three categories. But again, I'm going to try to give you examples to help you solidify this in your brain. Let's say a public health specialist wants to determine how adults stay active and exercise. So she finds a large group of adults to survey, and she asks them, is your primary means of physical activity walking, jogging, swimming, playing basketball, playing football, playing tennis? And they respond to the survey. What would you say is the level of measurement? I would say that this is nominal. I would say we're simply categorizing. Maybe you could say ordinal if the survey was worded a particular way. If the survey was worded like no activity, walking, jogging, running, sprinting, then there's a natural order to those categories. But if your survey includes things like jogging, swimming, tennis, volleyball, golf, it doesn't really make sense to say there's a particular order to those, because who's to say that tennis is more active than volleyball or volleyball is more active than tennis? It depends on your skill level and how much you're really trying. So I would think that this example is particularly an example of nominal, right? We're putting things into categories, we're putting individuals into categories, but there's not naturally an order to what sport you play or how you get your physical activity in.
Could you say that it includes etc. Like at the end, like it just...
Did you see that? Could you just say it's nominal too?
Maybe. I don't know. I'll have to think about that. Here's a new example. If somebody asks you, how satisfied are you with your access to healthcare services in your area? And on the survey, you can either answer, I'm very satisfied, or I'm satisfied, neutral, unsatisfied, or very unsatisfied. What would you say is this level of measurement? Ordinal. Yeah, because there is categories, and there is a very natural order to these categories. So this is a perfect example of ordinal level of measurement. Okay, this morning I step outside and on my porch I've got a thermometer that looks exactly like this, and I look at the thermometer and I measure the temperature outside by looking at it. It's kind of a random variable because before I step outside and look, I don't know what it's going to say. And what would this level of measurement be? Is it nominal, ordinal, interval, or ratio? Interval. Yeah. So this is an interval level of measurement. I'm not simply putting things into categories, And it's not just categories with an order to it, but this is a level of measurement where the differences between temperatures has a meaningful interpretation. Like, if I say, you know, the temperature here is 80 degrees, and in Tulsa, it's 90 degrees, then like a 10-degree difference is something that we can kind of wrap our heads around. You know, a 10-degree difference between 80 and 90 is a lot of ways physically similar to a 10-degree difference between 40 and 50 degrees, right? We kind of interpret differences in temperature as being a meaningful step. And that's what we mean by interval. I'll come back to this. I'll come back to this one. We'll do another example first. Okay, now we're surveying a group of people and asking, how many minutes per week do you spend in high-intensity cardiovascular exercise? So people are reporting a number of minutes. Is this nominal, ordinal, interval, or ratio? Ratio. And the reason that this is ratio is because 0 on this survey response literally means you don't do any cardiovascular exercise. 0 means 0. And it's ratio because ratios between measurements mean something. If I spend 20 minutes per week doing intense cardio and you do 60 minutes per week in intense cardio, it makes sense to say he spends 3 times as much time doing cardio. So it's a ratio level of measurement because ratios matter. Ratios are meaningful. Back to this one. If it is 10 degrees here and it's 20 degrees in Tulsa, is it twice as hot in Tulsa?
No.
No. That would be kind of a dumb thing to say, I think, you know? If it's 3 degrees here and it's 1 degree in Tulsa, is it 3 times as hot here? No. And the reason that this is interval and not ratio is because 0 on the Fahrenheit scale is practically meaningless. In fact, 0 in Fahrenheit is not the same as 0 in Celsius. Even though you're measuring the same thing, 0 does not have a real interpretable meaning. And so while the differences in temperature are meaningful to us, ratios don't matter, and 0 is really just an arbitrary point that we've defined, but it doesn't really mean there's 0 temperature outside. There's not 0 heat outside. There's still a little bit of heat, you know. And so this is only an interval level of measurement, whereas this would be a ratio level of measurement. Okay. I think we might have even talked about this last time, but if I say sample mean, I'm talking about taking an average. And I've got some really fancy notation that you might see again in the future, so I want to explain what it means. This X with a little bar over the top means sample mean. I might say X is my random variable. And if you ever see X with a bar over this, that means I have taken a sample of measurements and I averaged them together to find the sample mean, and the little X bar is talking about the sample mean. So that's what shows up here. On the right side of the equation, we see N. N is the number of individuals, or the number of measurements that we are averaging together. And then what is this giant thing? This is the capital Greek letter sigma. And if you see a capital Greek letter sigma in a math formula, that means we're going to add a bunch of stuff together. Particularly what it means here is that I take the sample mean by taking an average. And the little X with the subscript K is saying we're talking about individual measurements. The capital Greek letter sigma is saying add up all of those measurements. And then when I multiply times 1 over n, it's like dividing by the number of measurements. So again, this is the same average that you're used to taking, where you add up all of the individual measurements. This would be the kth measurement. So if k is equal to 4, then this is the 4th measurement, right? And we're going to use a subscript to denote the different measurements. Okay, hopefully that makes sense. The sample median is the middle value. After you order the sample measurements, you pick the middle value, that's the median. The sample mode is the most frequent measurement from a sample. Did I say that last time? I think I did. I feel like we talked about that. So right here, with these 5 numbers, 18, 12, 18, 10, 15, what is the sample mean? Is it 14.6? Or did I do that wrong? Okay, thank you. Thank you for checking me. So that's the mean. I might say x bar for the mean, right? The sample median, and sometimes you'll see the sample median given by an x with a little tilde on top. If you see that, I'm talking about the median. The straight bar is the mean, the tilde is the median. That would be, that's easier. What would that be? 15, because it's the middle number. And then what about the mode? 18. Yeah, because it appears twice. So that's the mode. Okay, everybody feels good about mean, median, mode? Good, good, good. So here's a question. When is the sample mode meaningful? Like for what kinds of questions? And this is a hint. The answer is either for discrete random variables or for continuous random variables. If I have a discrete random variable, like the number of eggs I find in a bird's nest, and I walk around and I look at, like, I don't know, 50 different nests and count eggs, would it be meaningful for me to tell you what the mode of that sample is? Like which number is the most common one that I come across? Yeah. Okay. So it works for discrete. It works for discrete random variables. On the other hand, let's think about a continuous random variable. A continuous random variable could be the height of a randomly selected MNU student. I know that when we typically measure somebody's height, we report our answers as if it were discrete. Think about this for a minute. When I tell you that my height is 6'2", it's probably not exactly 6 foot and 2 inches. It's probably like 6 foot and 1 inch, but like 1.8 8, 7, 5, 4, 3, 2, 1, 6, 4, 5, 1, 3, 1, 1, right? Like, it's probably not an exact clean cut, boom. Like yesterday I was 6'1", and then today I grew an inch, and now I'm 6'2". Like, people don't grow in 1-inch increments. People grow on a continuous spectrum of heights. So if we were really being honest about height, and you had a way to measure everybody's height down to the atom, it would be more of a continuous random variable. So let's imagine that. Let's imagine a true continuous random variable, like we were going to measure somebody's height down to the atom. Then I might get something like this. I might get a situation where, and let's pretend that height is like normally distributed. And help me out. Let's say the average person is what height? 5'8". Does that sound good? So that would be 68 inches. Let's say the average height is 68 inches and the standard deviation is maybe 6 inches. So now I've used Excel to kind of simulate this idea of like taking a bunch of people at random and measuring how tall they are in inches. Does it make any sense for me to tell you what the sample mode is? No. So the sample mode doesn't make sense for continuous random variables because technically you will never take the same measurement twice. Some people might appear to be the same height until you really measure precisely enough. And as long as you measure precisely enough, you'll find that they were slightly different heights. You know? Maybe it's hard to tell. Maybe it's initially imperceptible. Maybe they round to the nearest inch. But if you're really being careful about it and really being precise, then there's going to be a small difference, you know? Okay. So for that reason, we say that the sample mode is not meaningful for continuous random variables. It's only meaningful for discrete. Okay. When is the sample median meaningful? And the answer to this question is either nominal, ordinal, interval, or ratio. Or more than one. There maybe is 2 or 3 or I don't know. You tell me. When is the sample median going to be meaningful? Let's go through this one at a time. So the median, remember, is the middle of the sample measurements. This was an example of a nominal level of measurement, right? Where we're just sorting people into categories, but there's not a particular order. Would it make sense if I got the results of this survey and said, I'm going to calculate the sample median? No. Because if you're asking what's the middle measurement and everyone's just telling you their favorite sport, there's no middle of favorite sports. So it does not make sense if your level of measurement is nominal. Hold that thought. Hold that thought. What about this? If I asked a bunch of people how much exercise they got in minutes per week, and I say, I'm going to take the sample median, does that make sense? No. Yes. I could, after getting the results back of the survey, find the middle amount of exercise, right? The person who got the middle of the entire sample. That makes sense. If I took a bunch of temperatures in different cities in the United States, would it make sense to find the middle temperature? Yes. So for interval level of measurement, it still makes sense to say what's the middle of my sample set. This is the one that we might have to think the hardest about. If I had a ordinal level of measurement, like the results of this survey, would it make sense to ask what the middle response was?
Yes.
Yeah. And let me make a little example. What if I did this survey and these are the results I got? What if I had, 700 people say very unsatisfied, and 400 said very satisfied, and 400 said satisfied, and 300 said neutral, and 50 said unsatisfied, right? Can somebody tell me what would be the median? What would be the sample median here? Do you know how you'd begin calculating that? Yeah. So if you want to find the median for ordinal data, first step, find the total, find the number of people you surveyed, right? So that's 400 plus 400 plus 300, that's 1100, plus 700 is 1850. So the middle response of this survey would be 1850 divided by 2. The middle person is going to be the person who responded after 925. And then what we do is we subtract these numbers. We go down the list, subtracting numbers away from 925. Sounds crazy right now, but bear with me. 925 minus 400 is 525, right? Okay, 525 minus 400 is 125. 125 minus 300 makes it go negative. And that means neutral is going to be my median, okay? Whenever you switch from positive to negative, that one is the median. Let me come up with a new problem for you. Same idea, but we're going to do it like this. Let's say these are my survey results. We find the total N, which is 17, 19, 2,650. The middle is going to be halfway, so 2,650 would be 1325. Because I'm dividing by 2. Sorry. 1325. And then again, we take 1325 and we start from the top of the list. We say 1325 minus 900 is 425. And then we move on. 425 minus 800 is going to go negative. And so this time the median is in this category, in the satisfied category. That would be the sample median, the satisfied. So you can take a sample median for ordinal levels of measurement. And that's what I mean when I'm going to tell you the correct answer here. The sample median is meaningful for ordinal, interval, and ratio levels of measurement. But it is not meaningful for nominal levels of measurement. Okay, last question for today. When is the sample mean meaningful? That's the average, right? When is the average meaningful?
Interval and ratio.
Yeah, there you go. So he's got the answer. Yes, the sample mean is meaningful if you have an interval level of measurement or a ratio level of measurement. It is not meaningful if you have a nominal or ordinal level of measurement. So our example for nominal was like, what's your favorite sport? There's no way to take an average of that. You got to have numbers to take an average. Same thing for our satisfied, unsatisfied survey. You can't take an average of that because there's not numbers. Interval level of measurement, you can actually take average temperatures, and that works. That makes sense. People like average temperatures. And then our ratio example was like number of minutes you spend exercising per week. Of course, you can take an average of that. Of course, it makes sense. We like to interpret things like that. So we have only used less than an hour of class. But like I said, this class is going to start slow. It's going to feel like it's easy. And then throughout the semester, it's going to get spicier. But like I said, I wish I could have printed off the homework for you today. I didn't. If you want to see today's homework, like the types of problems that are going to end up on test. And by the way, there's a few new faces, right? There's like 4 people at least here that weren't here last time. So let me briefly recap what I said last time. Last time we talked about the syllabus. So if you weren't here last time, please read the syllabus, okay? That's on Moodle. Read the syllabus. I said I don't take homework grades. So I'm talking about assigning your homework. I'm not going to grade your homework. I'm not going to pick up your homework. You're not going to submit your homework. You're going to keep your homework. The homework questions are a test review. Your test is going to look exactly like the homework problems. I'm probably just going to copy and paste homework problems when I make your test. So still, spend some time practicing the homework because you want to be ready for the test. How do you find your homework for today? You're going to click on course materials. It's going to take you to this webpage, and you're going to click homework assignment. And then bam, that's your homework assignment for today. I could put any of those questions on your first test. All right.